So let's continue looking at pF. So we just did some work with schedules. We have a simple schedule in. We've mentioned that a converse to the existing configuration, which is to have one rule which blocks during a window of, say, 14 through 1430, and another which permits. The alternative would be to have one rule which permits with a schedule outside of our maintenance window. So just as a quick extension, let's say restrict access to RDP during, let's say, maintenance window using pass rule. So essentially this rule should match our maintenance window schedule and permit traffic outside of the maintenance window schedule. So presuming the maintenance window is, let's say, Sunday midnight through 4 a.m., then the schedule should permit all but. So we'd get rid of these two rules, and let's kill these. So as it currently stands, RDP will not function. And by the way, let's take a look at firewall network address translation. This 3389 maps out and creates a rule automatically. If we try to connect now to 75.4.3389 or 168.1.104.3389, then that's there, but the rule isn't. So now we have to independently create a rule. But we first want a schedule that matches our criteria. So we go back to schedules and we modify. So here is our RDP block or backup maintenance window, which should permit maybe all traffic except this window. You could use this rule as well, which would be everything but this window, or the RDP block to make it more specific. Either or. Just so long as your backup system is able to actually access the nodes. So you want to make sure they're not blocked as well. So let's click on edit for the RDP block. So you essentially want to modify the existing rule so that it's no longer this restricted window of 14 through 1430, but all times we want to permit access. So basically all day except. Now you can add times to the rule, to the overall rule. So we want to permit traffic, let's say, since 0 through 4 a.m. on Sundays is the window that's of concern to us. Let's disable Sunday for now. So we want Monday through Saturday, 24/7 to permit access. So through 23, all the way through 23:59. That covers the whole Monday through Saturday range. Let's just double check that. So Monday through Saturday, no problems. Maintenance for RDP. Actually, let's edit this. It's just going to be permit access. So permit RDP. That adds a time. Now you add another time. You want to say, well, Sundays, how do we treat Sundays? Well, all but 4 a.m. through. So say 4 a.m. or maybe 4:01, just to be clear, but starts at 4 a.m. through 23:59, permit RDP. So now your rule is extended. So Monday through Saturday, no restrictions. Sunday, however, 4 a.m. through 23:59 will we permit RDP. Otherwise, RDP will be blocked. So let's say instead of blocks, permits access to RDP, and RDP permit, and let's just say all but maintenance window. That should fit in there as a description, and that looks good. So we have two time ranges. Let's click on save. So now RDP permit Monday through Saturday, all day, all night. Sundays, however, midnight through 4 a.m. not permitted. And in terms of rules, let's take a look at our firewall rules. Now we want to create a new rule. It could be based on an existing rule. Let's say to SSH and just modify the 103 to 104. So we'll click add based on an existing rule. And instead of 103, we want 104. And instead of SSH, we want MSRDP to RDP. And then we want to tie in the schedule. So let's make sure we attach that schedule of permit RDP or RDP permit, either or, and click on save, and that should adjust it accordingly. Let's actually apply the changes. And there's our permit rule. It's now in permit state because we meet the criteria. Again, here's the criteria. Monday through Saturday, no problems. Sunday, 4 a.m. through 23:59. So we actually have to record during that window to see this bomb. And there we see it connects, no problems. And how about the other IP? Let's pop over to this other shell here. Let's try 75.104. So we'll telnet 192.168.75.4. That is 3389, not 104. And that connects as well. That's just the NATed face to it, the NATed address. So that works. So this is the workaround rule. One rule which permits all but 4 a.m. to 2359. And that rule could apply for the maintenance window, but you'll need an exception to be sure that your backup device or your backup system is able to get in there. So define rule or schedule that permits access all but Sunday midnight through 0400 hours. That looks good. So now let's move on to another area, logs. So a comprehensive set of logs are provided with the firewall. So comprehensive logging facility covering basically all facets of firewall operations, with the ability, if necessary, to log to remote syslog instances. And that should come as no surprise, as it is, of course, a BSD implementation. So your firewall, pFsense tracks everything. Let's close this out. Pretty much any and any facet of the system. All of these failed attempts, successful attempts, anything we tell it to log, it logs, it tracks it. Any changes to rules, user logins, etc., all of that's tracked in different areas. So where do we find it? Let's navigate to status, system logs. We've somewhat looked at the area, but not comprehensively. So peruse system logs. And this can be found obviously in status system logs. Whenever there's a problem with your firewall, this is the place to consult. So for example, with those instances of being blocked, we check the system logs firewall to get some more information before we delve into there. So the last 50 system log entries, this shows if the firewall has been reloaded, if it's been synced, if any users have logged in and from which IPs. So you can determine, and we know that the default limits to 2 simultaneous connections, which can be extended if necessary to support additional users. So we said mention the maximum processes. Maybe you need 5 users to connect. You up it there, and that'll give you additional users. So let's modify that. We'll click on save. That's going to refresh momentarily. Close this out. Status system logs. We're back in the mix. And the fact that we've just made a change is actually reflected. However, recall that logs are automatically listed in ascending time order. So you'll find the latest entries towards the bottom of the log. And as you can see, 1557, 1600 hours, and so on. So it's just about 1600 hours. And this is where you'll see the latest entries. You can filter by keywords. So let's say you're looking for something of particular interest, maybe reload. So you search for reload and you'll see all instances of the firewall being reloaded. Wipe the criteria, of course, that goes away, and it shows all the instances. And it shows from where you've connected. It shows the script that was used to log in, because you can log in from front ends outside of that particular item. Here we see an entry that web configuration has been changed, and that's to allow more processes, no differently than increasing the number of Apache processes for web services and so on. And these are the last 50 entries. There's the ability to clear it out, wipe it out, and the fact that you've actually cleared it out will be registered. The system tells you the kernel boot log file. This is a fresh instance of the log. That's your general system log file. It pertains to issues that pertain to the system overall, no differently than an operating system. So think of this as your var log messages. So let's just list them all out. So you've got the general, and this is like or akin to var log messages. General details concerning the health of the system, whether or not services have been restarted, and so on. When you clear things out, they're gone, so you won't expect to see them, and there's no recovery unless you've backed the system up. The firewall log. So in the firewall log, what we expect to find are entries related to firewalls. Notice that the menu changes accordingly. So in the general system log, you've got subtabs: general, gateways, routing, resolver, wireless. We can quickly go through this. Let's just notice that status, system logs, general. General is a subtab of system. So really it's system and then general. General is a subtab, just to be clear on that, because each has its own world, if you will, of entries. And that should be clear. And within system, you've got other entries. So here's a gateway. So occasionally, pFsense checks to ensure that the gateway is available for sending traffic out, so on and so forth. When DHCP is down, this could have been a power loss. It could have been a trip in the default gateway. It could have been a reset because of an update, a patch, etc. This is just a message to indicate that the server from which PF obtains its IP address, or if it's hardwired, is used as an upstream gateway, was down at that particular point. So on this particular date, at that particular time, it noticed that it was down. So on occasion, pFsense is checking to ensure that the system's up, that remote system's up, and that's for the gateway. So let's just include that as well. And there's so many menus here actually. So system, general, and let's actually clarify that system general. It's going to be system gateways. So it's within the subtab of system. So system gateways details ability to communicate with various known, let's just say known gateways, including upstream gateway. So if there's any trip, because that could interrupt communications, you should see some problems there. Routing, and this tells you how the routing engine is doing. And there are dynamic protocols supported, so if those items are configured, so RIP or any of the protocols, OSPF, you should see them here. Also, anything related to IPv6 configuration, which is provided via automatic configuration, will show up as well. Sometimes you'll see no prefix found, advertisements disabled, which will reduce the amount of traffic on the wire. In other words, the upstream router isn't producing or providing any IPv6 information, so you'll see some verbiage in there. The resolver pertains to DNS, so you can look for DNS information in here. You'll see that it read etc hosts on that date when it came up, and that it's using these two name servers at this time when it came up, and that it's ignoring its local host name server because it has two functional name servers. And any problems concerning or just general notices concerning resolution should be found in this particular item. It says it found possible DNS rebind attack on this particular node. Could mean that the node needs to be patched, so it could be exposed to that particular exploit, and that it's read etc resolve conf, picked up 2 addresses from it on various occasions. Every time the system reboots, expect it to find new information. There are no wireless interfaces, and it should see no wireless packets. PF can be configured to route across wireless. If you have these all-in-one boxes, or you buy from pFsense a box that supports wireless, then you should see wireless details. It should be able to bridge your wireless clients and route them out accordingly. That's a general system tab. Now firewall, this is where it gets interesting, of course, because this is certainly of interest. And again, system, firewall, DHCP, all the other protocols come up. The firewall menu lists with all these searchable fields the common actions: pass, block, and reject. As we've mentioned, pass allows traffic, and that's indicated with green with a play symbol. Block and reject will be represented with their red symbol with an X, but reject, of course, sends a gratuitous message back to the client. If your rules are set to block, then you should see few to no reject entries, but if you have rejects because you're sending gratuitous messages back to the client, then you should see those as well. The default view is the normal view. It's not updated on a recurring basis as the dynamic view is. So here are all our block entries. Let's just filter this out. You can pick apart IP and TCP headers looking for specific bits of information. So for example, when we're troubleshooting RDP, we'd be looking for 3389 as a destination port. But you'll see permits and rejects if the rules log on permits. So far it seems as if it's all rejects. Here are the 50 matched packets that have flowed through the firewall so far across what appears to be 1 day of RDP activity with a variety of connection points from 7592 to 101 back to 92, etc., trying to get to 104 on its 3389. And you'll see the protocol states, and then below you'll see translations of those TCP flags, with, of course, S being SYN, and other packet types or states, A acknowledged, so on and so forth, showing up as appropriate. So these are the rejects. If you look at all the packets, just filtering pass, block, reject, etc., you'll see all of them accordingly for 3389. When you don't see passes, it means that the rule isn't logging on a pass. So for example, say we take firewall rules, take a look at, say, this 3389, the rule is not logging when it is successful. And that's a default because that reduces the amount of the log footprint. So for example, log packets that are handled by this rule, this is your pass rule. And if you update this, this actually should be updated. So RDP to Linux CBT Win2 or to 104. And now it'll log traffic that has made it successfully to that node after we've applied the changes. Back here, refresh, and continue, and this should show us the latest entries. So now if we source a new 3389 session out, which should be permitted, we should see that log entry pop up shortly thereafter. If we do a refresh on this node, click on continue, it's a form, and there's the pass entry that's just come through at 1609 GMT. And this is a pass on the WAN interface coming in off of 192.168.75.92 on a high port of 5383 to 104.3389. It was a TCP SYN packet. Stateful firewalls will associate or correlate sessions. So the SYN came in, and so long as the server or the backend recipient responds with an acknowledge, it qualifies, or that session qualifies as a related session, and makes it a stateful session. As we've mentioned, from the logs you can automatically block packets, but be careful of this. So for example, if you do an easy rule to block this session or to pass it, you'll override any existing rules. So supposing we want to block this node, we click on block, this will create that new entry. It creates an alias and it creates a new entry, so it has 101/32, 92/32. These two nodes will be blocked as a result. So if we take a look on a separate window at the firewall rules, notice that our connection back there finally timed out. Let's close this and take a look at the latest entry that's been written. So we'll do firewall rules. We should see a new rule. It places a rule at the top because the firewall rules are read top down, so the blocks usually should be placed at the top of the rules. So for example, for Bogan networks or RFC 1918 networks or the loopback network, they should be placed towards the top. That's general firewall rule management best practices. So let's just note that as part of this system logs, and let's go back into here. Actually, we've already moved on. So B is going to be status firewall, and let's just note that rules can be auto created from log screen and will appear at the top of the list. Let's say the rules list, and as a separate note, place block or reject rules atop your firewall rules list as best practice, as rules are read top down. So your block should come before your denies, especially the important blocks, the common blocks that you expect to find. So that's why you'll find this rule at the top. So it's referencing an alias, which can aggregate n number of nodes as opposed to creating multiple entries. So this is an alias pointing to two separate nodes. If you take a look at the log entry, let's go back here for a moment. This is the actual alias called easy rule block hosts WAN. So it's just a list of hosts that can be found on the WAN. Take a look at aliases. Let's just do a reload. Actually, it's blocking us now. We're coming off of this particular IP address, so we're not able to connect to it. And that is an issue. Now, if we try to connect, let's say, to 1.1, which is the far side. So let's do a 1.1 connection point here. Let's see if it allows us to connect. It's not allowing us, so we've actually blocked ourselves out, which can be an issue. So how do you connect if you've blocked yourself out? Well, there are a variety of methods, but we still have our VMware interface going. So let's take a look on this side. So from this node, so long as we have access into the node, we can flush our firewall rules, and we can take a look at them. So for example, from ubuserv1, which is on the inside, we should be able to, from the console, connect to it. Let's do Control Alt, and this is fine that it happens because sometimes in actual production we do block ourselves from the firewall. That's a common thing. It's not unusual. So this is why we test these things out, and we have ways of backing out, and we use time-based rules. In the event that we block ourselves, eventually we should be permitted back in, and different tricks to work around these problems. But from this node, let's get a session going to the firewall. We should be able to connect to it from here. So let's pull up an instance of Firefox, and then we'll just drop that rule. That rule must contain the IP address of the Mac OS X desktop from which we're connecting. So here we see that this is looking good. I understand the risks. Connect me to the server. Let's scroll down a bit here just to tell it to let me in on this SSL, confirm the exception. Now we're in. So we actually haven't lost access to the server, to the pFsense firewall server. Let's kill this out. We don't want it to remember anything. Actually, we told it to remember it, so we'll kill it at some other point. So let's take a look at the firewall rules. In fact, back to logs. Since we know that we're being blocked in this particular case, let's do a system logs and firewall, and look just at blocks. Filter this out. Scroll to the bottom. We should see that the node is actually being blocked to connect to it. So somewhere in here we should see the IPs trying to connect to it. So 1.102.75.1, those are old 75.9, that's NBT or NetBIOS. Let's scroll up and try to find some TCP activity. These are just general packets coming in. The packets do flood in, so you have to look through this. Let's look for a destination port of 443 and see what comes up. So here are all the 443 entries that are being blocked, and we know we should be somewhere around 4 or so. So let's see what comes up. We'll need to scroll through. There we see some additional entries. These are the last 50 entries. So we're being blocked, 7592. And that's because of that rule. So let's go back to firewall rules and kill this. So this easy host, notice it's blocking 101 and 92. 92 is the IP address of the Mac OS X instance that we're using as a front end, and 101 is our other system Linux CBT build one. So we want to kill this rule or disable it. Let's say we're not sure. You can disable it, apply the changes, navigate back to your node. You should be able to connect. So let's pop back over and let's do a refresh. This time not of 1.1. We should just be able to connect to 75.3, and voila, we're back in. And here we see the aliases. So we wanted to look at the firewall aliases to see what constitutes this list. Click on edit and you'll see that it comprises of 2/32s and they're blocks. So this was entry added at these times, 101, so on and so forth. You can remove one of the nodes, maybe block one of the other ones, or kill the alias altogether, kill the rule altogether. Now if you try to kill the alias and it's while still associated with a firewall rule, it of course rejects that motion. So the thing to do is kill the rule altogether. So be very careful when using system logs to assign rules, because you can kill or disconnect your access. So let's just note that, and let's just double check this for a moment. Let's just pop that in. So be careful not to, let's say, block, reject your IP when, let's say, dynamically assigning rules from system log area. That's certainly a problem that can crop up, and that'll force you to have to connect using a different interface. So that pops in the entry. Let's go back to our system logs again, back to firewall. So we said this is the normal view. It isn't updated. Ajax or any means of dynamically refreshing the page is currently not in action. So as a consequence, you'll have to refresh the page to see the latest traffic as you see fit. So in order to see a dynamic view, you flip this screen to dynamic, and this will refresh on a recurring basis, showing you the latest traffic. Now the default, and you can pause it, by the way, the default is to show the latest records towards the bottom of the list. So if you're looking for that, take a look there. Through the System Advanced, you can switch that out to have the latest items sorted towards the top of the list, which may be more convenient. And you have a summary view, which shows us graphs of the various blocks, rejects, passes, and so on. So just as a general ratio, the blocks are 82% to 18%. So considerably more blocks than passes from the WAN interface to the LAN interface. The majority of interfaces coming on the WAN, or the traffic that is, coming in on the WAN, only a handful on the LAN. The majority of the protocols in use, as we expect, common protocols. The UDPs would be broadcast traffic, of course. So the 75.3 gateway interface of pFsense is fielding a lot of UDP related broadcast traffic. That's why it's such a big percentage here, because it's participating in a LAN that's chatty. It's broadcasting a lot of stuff. So this gives us some graphs. But if you just want to see the data as it moves, use the dynamic view and have a look at the traffic flowing through the firewall. And there we see some packets, destination outbound. So the nodes, one or more of the nodes on the internal net, in this case 102, is trying to communicate with these nodes, and it could just be security updates from Windows. We'd have to look up the addresses to determine that, and you'll see those packets accordingly. So this is a straightforward interface, and obviously you can clear the log, wipe items out, etc., and get a fresh view by clicking on clear logs. Anything related to DHCP, we know that our server on its 192.168.1 interface and again status dashboard shows all of the interfaces. So on the LAN interface, our pFsense system is a DHCP server. So the DHCP menu gives us the typical DORA correspondences between clients and the DHCP server. You'll see the addresses that have been assigned. It doesn't show you the active leases in a tabular form as we can from the DHCP leases screen, which we've already looked at, but it does show you the correspondences between the MAC addresses that have requested various services from it on various interfaces. So EM1 is the interface on which DHCP server or services is running. For n number of interfaces, you can run DHCP services within pFsense. If you've got other DMZs like ops 1 through n, optional 1 through n, you can run DHCP there as well. So these are the addresses that have been leased out, 102, 103, and 104, to correspond to the 3 nodes that are there. Again, you can always get a cleaner view by looking at DHCP leases. This should show you the active leases. We know the defaults for 2 hours, and we know there are 3 nodes on that subnet that are using addresses 102, 103, 104, and we expected the Winbox to pick up 104 as it was the next address on the list that was available. So inside System Logs, DHCP, have a look at this just to see if there are any issues with handing out addresses, just to see if there are MAC addresses or systems on the wire requesting services that should not be, maybe rogue systems, or just to see if there are any problems with the DHCP server software running on pFsense. Authentication, well, pFsense can function as a portal as you find, let's say, in public spaces such as airports, hotels, etc. So you can see how many people have authenticated through it. It can also function as an IPsec gateway, PPP gateway, VPN with respect to various protocols such as L2TP, PPPoE, IPsec, etc. OpenVPN, which has its own entry, and it can also load balance. And of course, anything related to NTP to keep its time synced should be reflected in the NTP menu. And the settings, you can determine how many items are to be displayed, adjusting it accordingly. You can alter the reverse to show the newest entries at the top, as we've mentioned, so it's in this menu. And you can also log to remote systems from this menu, remote syslog service, so long as you allow the remote service to accept traffic from the IP address of your pFsense firewall, then that can be configured in settings. So that's where you'd find that particular entry. Just navigate through this to get a sense. So system log, system, gateways, firewalls, these are the additional options. Rather straightforward interface. It provides us a plethora of information. And on top of that, as we've mentioned, you've got other tabular presentations of data, such as your basic dashboard, DHCP's 4 and 6 leases, all presented in a tabular form. Information concerning other items as well. So this is your log interface. We've looked at it. You can see perhaps the most interesting area is going to be the firewall area. So you take a look at system logs firewall to see what traffic's flowing through it. The new sort order should now show the most recent packets. Here again, we're seeing broadcast UDP-based traffic. Well, this is actually 137, so it's not broadcast, it's unicast. But this is Windows services, so 101, which apparently is running Samba services. 101 is our Linux CBT build 1 box that we connect to often, is running Samba and attempting to send packets to the gateway. So it is broadcast traffic, not to the gateway, to the broadcast. So this is broadcast UDP traffic on behalf of NetBIOS for Windows, and the firewall interface fields it because it's broadcast traffic, which drives up the UDP count, but it's blocked because it's not permitting that traffic to flow through. And then here's multicast traffic on 224, and here's TCP SYN 443 that's been permitted, and other entries that have been permitted. And if we flip to dynamic view, again, the latest items will be at the top. The page will refresh on a recurring basis, showing us the latest packets. So let's say we try to telnet into 3389 on that node. That's going to be a new packet that comes in momentarily. So we also launch another session to 101 or 102, that is 1.102 on 3389. That's going to pop up as a separate connection as actually 104. And you can see the refresh occurred in the background. So that's 2 sessions. So there is a packet that came in. Let's see what's happened here. So we've got 92 permit 104.3389, that worked, but we saw a block or blocks on 102 because these are incorrect. So during that time, 3 attempts were made to connect to 102.3389, but those failed, of course. And from that point, you can determine what to do with that particular information. Notice from the dynamic view, you don't have the ability to automatically create that entry. Currently, the packet's blocked. Here's a block for 224. And it tells you the rule that triggered the block. This is the default deny rule. If you want to learn more about why a particular rule was or has failed, just click on the icon that's associated with the rule and it'll tell you accordingly. So this is a default deny at the bottom, meaning this particular IGMP group messaging is not permitted. This one passed because there's a rule, a user rule that's written to allow it to pass through, coming off of 750/24 into 104. This one failed because of the default deny, because we don't have an explicit, so default deny. If we had an explicit block 3389 to 102, then that would be the rule that triggers before the default deny. So for information about why traffic may have passed or blocked, just click on the actual icon to the left of it. And anything with a plus sign will add, if it's red, a block rule, green, a pass rule for that particular type of traffic, allowing it to pass through the interface. And then again, you can search based on pass, block, reject, time, interface, so you can show all traffic, say on EM0 or say EM1, etc., and so on, if it shows up in the packet stream. But since these are L3 packets, L4 packets, you'll be searching largely on IPs and ports. So show me all packets that contain a source IP of, say, 192.168.75.92, which is our Mac OS X box. So here are all the packets we've generated, whether knowingly or otherwise, the majority of which appears to have passed, but 3 have failed earlier because of that rule that we had created. And in fact, click on this. Actually, this is a default deny. So this is a default. So this was block drop because of the default deny to 3389 at the time, because 102 didn't exist. This wasn't the 104 blockage from earlier that we saw, or the 104 blockage that we saw earlier, which was because of the rule that was automatically created. So there we see the entries, everything to do with 92, and it's showing a maximum currently of 100 entries. This can be extended. You can write regular expressions, for example, to match items, or exclamation to exclude, let's say, all of the hosts. So don't show me 92, show me everything else but 92. That's supported. Source destination ports, protocols, protocol flags, and so on. And those will be means of which you can parse through the traffic. So like any enterprise firewall, comprehensive logging support is included. The general place you'll find logs is status system logs, but there are other types of logs, such as DHCP leases, as we mentioned, which will provide tabular forms of information and so on. So let's move on.